Alright, so here we're going to talk about type 1 and type 2 errors, like what I said today, and we went over this in class. When we draw conclusions from a significance, we hope our conclusions are correct, but sometimes we'll be wrong. There are two types of mistakes we can make. Remember, they're type 1 or type 2 errors. Type 1 is when we reject the null when the null is true, and type 2 is when we fail to reject when false. So I call type 2 as FF. It's like F. So this is how I remember it. I say type 2, okay, takes 2F, which means we fail to reject, fail when false. And it always deals with H naught. So I fail to reject H naught when H naught is false. So type 2 is 2F, fail, false. So it's another way to remember it. If you don't remember your chart, you're going to type 2 happens when I fail to reject when false. F. Type Q gets 2F. However you want to remember it, you can. It doesn't matter. But type 2 is 2Fs, and the other one is when I reject something when it's true. It's a type 1 error. And then you can look at it here. This is the chart I drew on the board today, and this is a type 1 and a type 2 error. Happens here when I reject the null when the null is true, or when I fail to reject when it's false. So, potato chip producer and its main supplier agree that each shipment of potatoes must meet certain quality standards. If the producer determines that more than 8% of the potatoes in the shipment have blemishes, the truck will be sent away to get another load of potatoes from the supplier. Otherwise, the entire truckload will be used to make potato chips. To make the decision, our supervisor will inspect a random sample of potatoes from the shipment. Excuse me. The producer will then perform a significance test using the hypothesis. P has to equal 0.08 because that's 8%, it's 0.08. If it's greater than 0.08, it'll be sent away. Notice that the null is always the equal sign. It always has to be in the null. Where P is the actual proportion of potatoes with blemishes in a given truckload. Okay, so describe a type 1 and a type 2 error in this setting and explain the consequences of each. So the very first thing that I do is I would write down the fact that a type 1 error, right, is when I reject the null and the null is true. So I'm going to reject this when it's true. So what would happen would be I would send the truck away, right, which means P is greater, oops, not greater than or equal to, is greater than 0.08. So send the truck away. When really, okay, what's going on, really that my P is less than or equal to 0.08. Okay? So I'm going to say this happened when really this is true. Okay, so when really the null is true, technically we'd write when P equals 0.08. So we're good. That's what happens there. A type 2, remember it's F and F, 2F, so I fail to reject. So I fail to reject, which means I keep the truck. Okay, so I failed to reject. I keep the truck when really I should have sent it away. So I failed to reject. I keep the truck when really I should have sent it away. I failed to reject when it's false. So I don't when this is less than this, okay? So I don't send it away when really I should have because the value is that it's greater than it. Okay? The truth is that it's greater. And here's their long error. Type 1 occur where the producer concludes that the proportion of potatoes with blemishes is greater than 0.08 when actually the proportion is less. Consequence, the potato chip producer sends the truckload of acceptable potatoes away, which may result in loss of revenue for the supplier. Type 2 would occur if the producer does not send the truck away when more than 8% of the potatoes in the shipment have blemishes. The producer uses the truckload of potatoes to make potato chips. More chips will be made with blemished potatoes, which may upset the consumer. So these are the type 1 and type 2 and the consequences. We can assess the performance of a significance test by looking at the probabilities of two types of error. That's because statistical inference is based on asking what would happen if I did this many times. For the truckload of potatoes in this previous example, we were testing P equal to 0.08 and greater than 0.08, where P is the actual proportion of potatoes with blemishes. Suppose that the potato chip producer decides to carry out this test based on a random sample of 500 potatoes using a significance level of 0.05. Okay, so assuming 0.08 is true, the sampling distribution P hat will have, so shape, center, and spread, so it's approximately normal because 500 times 0.08 is 40, and this is 460. Both are at least 10. This is the N times P is greater than 10 part. This is what they did, the shape, so that's N times P is greater than or equal to 10, and N times Q is greater than or equal to 10, and that makes it normal, so it's approximately normal. Alright, that's what they were checking there. Then they take 0.08, it has to be your center, right, because the center should be the same as the population proportion. Then you have to find the spread, okay, so which is the standard deviation of P hat. So you have to put in your proportion, which is 0.08, times 1 minus 0.08, over the total, which gives me my spread to be 0.0121. Okay, so we know that it's approximately normal, right, with a mean at 0.08, so it's normal with a mean of 0.08 and a standard deviation of 0.0121. Okay, so that's what's going on here, 0.0121. So when that happens, okay, so this is the case, we need to know what the marker is to where 0.05, okay, significance level is right here. Alpha level of 0.05. That means there's only 0.05 left in the tail. Now, what I want to point out to you, because kids are like, well, how do I know to shade this side of the tail, 0.05, or this side of the tail? Well, if you look at the alternative right here, right, so if I write P is greater than 0.08, notice this is like an arrow, and it points the direction that you needed to shade. So in my normal curve, I would know that I need to know the marker for 0.05 over here. So I need to know that value. Okay? Now, this is your alpha. Alpha equals 0.05, which what it means is it's the probability that you could make a type 1 error. So the probability of making a type 1 error is always your alpha level. They're always the same. So if they were to ask you what's the probability of making a type 1 error, remember that it's just your alpha level. And you set that before you start your testing. Okay? So the idea is that if H0 is true, a decision to reject H0 is based on the data is a type 1 error. Okay? The sampling distribution, that's what they're showing you here. Right? So this line is where anything past here, okay, is where I'd reject, given that that's true. And so there's a 5% chance that I'm going to reject it when it's true. Everybody understand that? And so alpha is the same thing as a type 1 error, because a type 1 is when I reject and it's true. So I'm going to reject it right here at this level. And alpha and type 1 are the exact same thing. The shaded area under the right of the tail is 5%. Sample proportion values to the right of the green line at 0.099 will cause us to reject H0 even when it's true. This will happen in 5% of all samples. That's making probability of making a type 1 error 0.05, and that it's always the same as your alpha. The probability of a type 1 error is the probability of rejecting the null when it's really true. As we can see from previous examples, this is exactly the significance level of the test, which is what I just told you. The significance level alpha of any fixed level test is the probability of a type 1 error. That is, alpha is the probability that the test will reject the null hypothesis when the null is in fact true. Consider the consequences of a type 1 error before choosing a significance level. So what about type 2 errors? A significance test makes a type 2 error when it fails to reject the null when it's really false. There are many values of the parameter that satisfy the alternative hypothesis. So we concentrate on one value. We concentrate on the probability that the test does reject H0 when the alternative is true. That probability is called the power of the test against the specific alternative. The power of a test against a specific alternative is the probability that the test will reject H naught at the given significance level when the specified alternative value parameter is true. So we reject the null when the alternative is true, which is a good decision. So the power of a test is actually a good decision. Okay, so if you looked at that chart that we made yesterday, this is a good decision, because this is when I reject the null, okay, when the alternative is true. So if the alternative is true, then that means it's wrong. The null is wrong. So I reject the null when it's actually wrong, which is what I'm supposed to do. This is what we're supposed to do. That is the power of the test. Okay? The power is, what's the probability that I'm going to reject the null when I'm supposed to reject it? So the potato chip producer wonders whether the significance test of the 500 potatoes has enough power to detect if a shipment, say 11% of the blemished potatoes. In this case, a particular type 2 error is the fail to reject when P equals 0.11. Okay. Earlier we decided to reject H naught at an alpha of 0.05. If our sample yielded a sample proportion to the right of the green line, right, where P is 0.099, anything over here we would reject. What if P is 0.11? Okay, so 0.11 is over here, 0.1163, we're over here. Oh, so sorry, what if P was 0.11? Let's go back. That means that what if the actual P value, instead of being at 0.08, really is over here? Okay? How likely would we have been to reject it? So what happens is that what if P is 0.11, which means it's right here, okay, and we reject anything past this? Well, we're more likely to reject it. Since we reject H naught at alpha of 0.05, if our sample yields a proportion greater than 0.099, we'd reject the shipment about 75% of the time. So this is the actual truth, right, of the shipment. And we rejected anything past here. This probability is where they get this 75%. Okay? So type 2 error is 1 minus the power of a test. That's what else you need to know. Right? Type 2 is 1 minus the power of the test. So here is the type 2 error over here, and this is the power. We're going to look at this more in detail in your Inspire activity in class, so don't worry about that. The power of the test against any alternative is 1 minus the probability of a type 2 error, or 1 minus beta. That's the probability of type 2.